All right, here we go. We're doing talking about parent functions today, and what parent functions are. So, just a quick definition of what a parent function is. A parent function is just a function. Remember, we kind of talked about what a function is compared to a relation is on the last stuff that we've done. But remember, a function is a function that passes a vertical line test, and that only has one x value. My x values do not repeat in that case. So what my parent functions are, they're the functions that actually, I guess, originate all the other functions. So from them, we transform everything else. So we move things right, left, up and down, different directions. So, but every type of equation which produces a function has a specific type of shape and design with it. And so that's what we're looking at, is looking at the shape of these functions when we graph them and their equations. And you guys should be able to recognize what type of parent function it has just based on the shape or the equation. Okay, so we're going to start with real basic one, linear, guys. The equation for linear, and we're gonna do it in function notation. So f of x, which remember, this is really just y. So f of x equals x would be my linear. Again, y equals x. This is the parent function for a linear, and you can move it all over the place from there. So if I graph this, my basic function, or my basic graph, would be this red line here that goes on forever, but it goes through here through the origin. So every other linear, obviously there's no curve to this. You should be able to recognize linears by just no curve. And then if it's a parent function, it's right here in the middle. Every other function that looks like a linear has just been moved and shifted and all that kind of stuff. Okay? So that's a linear. I'd remember the parent equation and the parent function for that. A quadratic, the parent equation is f of x equals x squared. So whenever you see the highest power as a squared here, you know it's going to be some sort of quadratic. If I was to graph just this parent function right here, this one looks like a u that goes right here through the middle. This point is what we call a vertex. We'll talk more about that later, but there's the shape. So whenever you have the shape of a U, or it can be the upside down, it can be that way as well. So there's my parent equation. There's my parent graph. Okay, so that is a quadratic. Next one is a cubic. The functions, or the equation's really easy. A cubic is just x cubed. And the graph of this parent equation looks like so. It's going to start down here, come through the middle, and then wind back up there, and it'll go on for forever. This is moving up and right. This is moving down and left as well. So that's a cubic. There's my equation, and there's my graph for that as well. Next one we're going to cover is an absolute value function. So we'll go f of x, and then this is just the absolute value of x. So you put these lines around it. Hopefully you guys remember talking about these probably when you're in, I don't know, 8th or, I don't know, 8th, 9th, maybe earlier than that. The graph of this is very distinguishable. It's just a V that goes up, and it's right here in the middle as well. I kind of shifted it. It should have been right here in the middle. They can be upside down once you've transformed them, but the parent functions are right there. My exponentials, which you guys talked a ton about, these are f of x. And then this one's a little bit tricky. I'm going to go a of x. The feature that you guys got to know the most is this x is the exponent. So like I could have 2 to the x, or 3 to the x, or 4 to the x. I put a because these are all exponentials, but the parent functions, you just have just an x. There's not like x minus 1 or anything like that. So hopefully that makes sense. The a just represents for one of these numbers, and the x is always in the exponent, that's how we know this is an exponential here. And you guys, again, talked a ton about these in 9th grade. Again, the graph of these, they're like right close to the x-axis, and then they cross here and go up. They cross here at this point, 0, 1 for my parent function as well. It does go left forever. It never crosses this x-axis. That is your exponential. The difference between 2x, 3x, 4x is just how fast this thing climbs and how, anyway, but it still goes through 0, 1 and that kind of stuff. And then the last two, we're going to talk about square roots. So the equation's really easy. It's just the square root of x. The graph of this parent function starts here at 0, 0, and then it goes that one direction right there. I call it the story of your life function because it starts here and goes one direction. That's what makes it beautiful. Just joking. I'm sorry. No more jokes. All right, so that is our square root. Again, it'll never go into the negative for my parent function like that. It starts here and goes the one direction with going up and to the right. Okay. And then the last one is a square root or a cube root. So obviously my equation is just going to be the cube root of x. And this one's graph is going to look pretty similar to a square root. The only difference is I can go this way as well. So this one's going to go through here and then that away. So it kind of looks like a cube because the cube root's the opposite or the inverse of that. So remember the cube root went like this though along the y-axis instead of the x. So these ones do go left and right forever. They do have arrows on both sides, whereas square roots only has the arrow on the one side. So what I want you guys to be able to do is recognize parent functions. So if I give you, let's say I just give you a graph here, okay, and I say, hey, what's this graph's parent function? Well, you'd look at it and say, okay, is it quadratic? Is it cubic? Is it absolute value? Is it exponential? Any of these is what you're looking for. In this case, I've got myself a v here. So this v is going to be the absolute value. So this would be absolute value would be my parent function. And to know exactly, again, if I was to do my equation here, this would be, again, my parent function would be f of x equals the absolute value of that. But this just wants us to identify, well, what is its parent function? Again, I know the graph is not here in the middle like the parent function, but what is its parent function? Even though it's been shifted, that's what we're looking for. Okay, so let me give you another one here. Let's say we had, this graph right here. And I said, what is its parent function? Again, I'm going to look through my options here. And if you notice, this one's a U-shaped. So this one's going to be a quadratic parent function. Okay? The second thing I want you guys to be able to do is look at equations. So if I give you like 3x plus 1, and I ask you what is its parent function, you guys would tell me that that is a linear. The reason why that is because it's got x to the first power here. And it doesn't have absolute values. It doesn't have any roots with it, any of that kind of stuff. Okay? Let me give you another one. So let's say I said f of x equals 3x plus 2 squared minus 8. Well, because I have this squared, that makes this a quadratic at that point in time. Again, because of the squared. So linear is first power, quadratics 2. If it was a 3, then we'd call it a cubic. Okay? Or let me give you this. Let's say f of x equals 5 absolute value of x minus 8. And you guys would tell me that one is an absolute value because that's what we have there. That's that feature, absolute value. So you should be able to look at a graph or an equation and be able to tell me whether or not or what its parent function is. That's what we're trying to do, is just identify parent functions. All right, been your math moment with the